right, multiplying polynomials and multiplying functions. Okay, we're multiplying functions, which happen to be polynomials. These are our 5 that we're going to be using. So please just keep referring to that as you work through your programs. Work through these problems. You may not see it constantly when I'm doing it because I only have a finite screen here. Okay, this one says f of x times t of x. So we find f of x is here, t of x is here. We're going to multiply these two together. So f of x is 2x squared. Okay, and t of x is x squared minus 5x plus 10. We put parentheses around things with more than one term. Okay, and then we do what's called distributing. We take whatever's in front, or however many terms in one polynomial, and multiply it by each one of these terms. So it's like mini problems put together. So let's just, I really don't want to do it that way, but you take 2x squared times x squared. And so it's just like doing the exponent rules when you multiply bases. When you multiply bases, you multiply the numbers. 2 times 1 is 2. And then you multiply x squared times x squared, and you get x to the 4th. And then you do the same thing with the next one. 2x squared times a negative 5x. So multiply the numbers, or the coefficients, that's negative 10. And then you multiply x squared times your x. Add the exponents. So there's 2x's here, there's 1 here, so we have 3 altogether when we multiply them. And then you take 2x squared and multiply it by 10, and you're left with 20x squared. Okay, that's it. There's no like terms here, so you're done. Okay, next one. Moving down here, we have g of x times k of x. So g of x is 3x minus 2y, and k of x is 4x minus 5y. So we don't see them. G of x is here, k of x is here. And what you can do is you take each term of this one and distribute it to those two. So you would take the 3x and multiply it times the 4x, and then times the negative 5y. And then you take the negative 2y and multiply that together. So that's one way to go about this. I do like using what's called the tabular method. If you don't like this method, you can use your own. Completely fine with me. I'm just going to show you this one because this method tends to eliminate any major issues with forgetting terms or forgetting to multiply. So when I do this, I have a 3x and a negative 2y. So I simply put 3x here and negative 2y here, or I'm on the top, it doesn't matter. And then I have 4x and a negative 5y. So I put that in each box here. Each one of those gets a little, like, top of a box. Okay, and then we simply multiply. So I'm going to take this one and multiply it times the 4x and put the answer here, times the 3x, times the negative 5y here. So it's just like doing the distributing, but it's kind of in a nice little organized way. So that's 12x squared there, 3x times negative 5y, negative 15xy. This one, 2y times the 4x, would be negative 8xy. And negative 2y times negative 5y is positive 10y squared. Okay, and then we simply write this out like it's a function, like one of those. So g of x times k of x is 12x squared. There's no like terms to add it. So I just put 12x squared. 15xy and negative 8xy are positive like term, or I don't know why I said positive, but they are like terms. They both have x and y, and their exponents are the same. So you simply combine the coefficients. So remember, when you're adding, because at this point we're now adding, we're done multiplying, we're just combining like terms, exponents stay the same. Okay, only change the exponents when you multiply or divide. Okay, so you have negative $15. Well, you borrowed $15 for someone, and then you borrowed another 8. How much do you owe? Well, I owe $23. Okay, and then 10y squared, excuse me, does not have a positive sign here, but it is positive. So in order to separate the terms, we put a plus sign. Okay, there you go. Next, the term g of x times h of x. So simply write it out. G of x is 3x minus 2y. H of x is 3x plus 2y. All right, now these are very special. Maybe you noticed the commonalities here. This is 3x, this is 2y, this is 3x, that's 2y. The only difference is the sign on the 2y. The 3's are exactly the same. The sign on the 2y are different. That's it. And this makes these guys a very special thing called conjugates. Okay, conjugates are binomials with a different middle sign. That's it. That's what they are. And very special thing happens. So when I multiply these, 3x, negative 2y. See, it doesn't matter if I put this one on the side or on the top. So just be aware of that. So when I multiply these, I get 9x squared, negative 6xy, positive 6xy, and negative, that should be a 4, sorry, and a negative 4y squared. So you'll notice you have a 9x squared, a negative 4y squared, and these two guys in the middle, you owe someone $6 and you pay them back, you owe them nothing now. Okay, negative 6 and a positive 6, gone. That's 0. Big whopping 0. So all you're left with is 9x squared minus 4y squared. And that is what conjugates do. Okay, when you multiply conjugates together, one of their things that they do, when you multiply them together, the middle terms here always drop out, and you're left with the difference of two squares. Perfect square, difference. Called dots, if you recall. So that's exciting. Okay, multiply these two together. I'm going to write it out and set it up and have you try it. Okay, so it's 3x plus 2y, and then x squared minus 5x plus 10. So when you set this guy up, sorry, I want to use the edge there, there's no room. Okay, so when you set this guy up here, you need 3x and 2y are two terms. Okay, and x squared minus 5x plus 10 is three terms, so they just each need a spot. And you just simply multiply them together. So try multiplying, combining like terms, and writing your answer out. Okay, here's what this guy looks like when you multiply them together. Okay, it's x squared, and you get, these are your terms here. If you set it up like I did, those are the terms. And then when you do that, and it's mostly because there's this y here, if this y wasn't here, we would have some like terms to combine, but we don't have any like terms. So this polynomial actually has 6 terms, because when we multiply, there's nothing that's like. So that's pretty cool. Okay, finally, we come down here, we have something that says prove. So prove is a very special thing. It says prove that tx squared is x to the, there's that mess. Okay? In order to do that, there's something that you need to know. First, I'm going to write this out. So tx squared is x squared minus 5x plus 10. That's t of x. And you square it, and they're asking you if that's equal to x squared minus 10x. Yeah, this. I'm just going to write it. And it's very important when you prove something, nothing crosses that middle line. It's like a check, but we don't actually have a number to check it. You can't plug a number in to do this, because we'd have to check it for every single number that exists, which can't be done. So what you have to do is just prove that if you multiply this out, it's exactly the same as this. You don't subtract, add, or do anything else except just do the math on one side. If you could factor, you could have factored that. Okay? But we can't do that yet, so we'll just multiply. So it doesn't matter where you do your work. I'm going to do my work over here. So box it up. We got 3 terms. Two of them are multiplying 3 terms times 3 terms. So we're going to have a total of 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9 before you actually multiply. So you put your x squared minus 5x, 10 plus 10. And then x squared minus 5x plus 10. So why don't you try that out? Multiply. This is correct. It is equal to this. So once you multiply, you're going to combine like terms, and instead of 9 terms here, you're going to have 1, 2, 3, 4, 5. So you're going to combine some terms. All right? So try it out. I'll see you tomorrow.